Oh, hi everyone. This is my commentary for lecture number 6 on modeling human nature interactions. And if you look at this lecture, what we've done is that we've looked at several case studies of the ways population interacts with a limiting resource. In this case, for the most part, it's natural systems that pose a limitation, and there's this two-way interaction in which natural resources promote or impede population growth. At the same time, population consumes resources. So there's this a two-way interaction that is very useful to illustrate. So we've looked at, in this case, 3 case studies: the one with the deer in the Kaibat Plateau, the one with the Mayan civilization and their collapse, and then a generalized human nature model that we're going to be using for a couple of more lectures as we build models of more complexity. We're going to be using this template to add more stocks to this human nature interaction, and even look at different, more specificity in terms of the population, in terms of the natural resources. We're looking at other stocks as well. So I hope you're able to take a look at them and understand what they are. And this takes me to my next point. Where I expect you to be at this point in the class is I expect essentially 2 sets of skills. I think the first one is familiarity with the models that we've developed so far. You should be comfortable understanding the different stocks, the fluxes, the units, and sort of the logic behind the models that we've developed so far. Understanding that these models are not unique. These models are built to gain understanding about the systems, but there is really no unique way of modeling these systems, and so there's no right model, right approach, and that's why I'm asking you constantly to tinker a little bit with the models, change an assumption, change a way the model is formulated, run it, so you gain that familiarity with with the models. So that's the first skill. The second one is you should be able now to start assembling simple models of your own, and you can do this in as part of your first assignment, or you can do this for your own curiosity. And so I want you to start building maybe even simple stock models that put ins and outs and change the assumptions, change the parameters, look at the results. I really want you to get into into the modeling piece. So if you're at that stage right now, you're on the ball. If you're not, you need to play catch up and make sure that you understand, because we're going to be now moving into building models of increasing complexity. More stocks, more interactions, more complex feedbacks. So if you look at what we've done so far, we've sort of built to this point. I want you to feel comfortable with what we've done. Let's see what else I have about your assignment. I've received some papers from a few of you for review. Those look fine. Now remember that I'm not going to be okaying or not okaying the papers you choose to review. It's your choice. The criteria and the assignment are fairly clear. This needs to be something you care about, so it's your choice. It also needs to be something that's dynamic. It's a system that's dynamic, so it changes over time, and it needs to be something that you can simulate or you can treat using system dynamics. That means it needs to have clear stocks and fluxes in and out, so that it's amenable to system dynamics treatment. So that's the that's the gist of it, and the idea of this first exercise is to sort of for you to critically evaluate someone else's work. Probably a good strategy, as I've mentioned before, is to line this up with what you're going to do for your final assignment, in which you're actually going to be building a system dynamics model. You're going to be running it and getting results and critiquing the results and proposing recommendations. So I'm going to be sending those guidelines for the second assignment very, very soon. A little bit of more bookkeeping items. the class Dropbox folder is a shared folder among all of us. So the models that are there, if you were to run them from Dropbox, Vensim would simulate the system and will generate all these other files that will be stored in the Dropbox folder. We want to keep that manageable. So what I'm going to ask you is that if you actually run a model, if you want to change a model, just pull that out of Dropbox, run it on your own, on your own computer, so it's not shared with everybody else. And then if you want to post results or commentary, you've got Facebook, and you can load something back on the Dropbox. Just make sure that we don't clog the folder with unnecessary files, and because it's being shared by by 40 plus people at this point, so it can get out of hand very quickly. Let's say if 20 of you decide you want to run different models of the 10 or so that are on the Dropbox now, the Dropbox can get out of hand very, very quickly. So I'm going to ask you to run those out of the system, okay? And we also have this one-on-one Dropbox folders with you and me, and for that, that's primarily your folder, private folder, and you can do there whatever you want. So if you actually want to run something in that folder, perfectly, just that you can go ahead and do that. So that's pretty much it. I hope you enjoy the lecture, and next time we're going to be moving into more complex models and looking at sustainability issues using these models. So I hope you can understand what's going on right now, and that we can move forward then. Enjoy the lecture, enjoy the week. Take care.